In the coming decades, urban citizen and vehicle numbers are expected to substantially increase. To meet sustainable development goals, mobility will have to become more efficient. At the NCCR Automation, leading researchers are addressing different obstacles to achieve just that. They begin by teaching cars to navigate complex environments autonomously.
What I see as the main challenge today to make this vision of autonomy for urban mobility real is the fact that we don't have a clear idea of how we want these vehicles to behave. People don't realize this, but a lot of the regulations that determine how cars should drive today actually come from the Roman law for how shepherds should control their sheep, or how people on horses should behave, right, when encountering people on foot. One of the things that we are working on is how to make these regulations more precise so that we can make part of the software programs and the code that actually runs our cars.
A key aspect of autonomous driving is the split-second decision-making in an emergency. A race setting is quite similar in that regard. Researchers therefore constructed a racetrack in which they can push their algorithms to the limit without endangering anyone.
Here you see what the go-kart sees. It uses a LiDAR that projects lights into the environment and collects the reflection of it. This information is passed to the planning algorithm that computes a trajectory. So this red and green snake that you see in the middle of the screen, that is actually optimizing the progress along the tracks. So humans are actually pretty good drivers when they don't get distracted. For example, when they're trying to merge onto the highway, it comes very natural to a human being to understand that there's another lane of cars, and that when they try to or start merging, very likely the other cars will slow down a bit to leave room for them to merge. If you manage to take into account how the others react, the result is that the autonomous vehicles would drive much more fluently.
Fluent traffic, however, does not only depend on how well autonomous cars drive. Other elements of the mobility system are also crucial.
Congestion in urban networks is a complex phenomenon. And this is because you have many modes of transportation like buses, cars, motorcycles, bicycles that are competing for limited urban space. An efficient control strategy to manage mobility in large-scale urban networks is perimeter control of traffic lights. We choose some critical intersections in the city and we change the amount of green time so that this city center operates in an efficient regime with high flows and little delays. By influencing the flow of vehicles that is entering the city center, we're capable to avoid highly congested situations and decrease delays by amount of 15 to 20%.
Delays in urban transport can also be reduced by more efficient distributions of vehicles. On-demand services like Uber or Lyft play a special role in this regard.
Some areas that has high requests for rides may not have a lot of available vehicles around. With so-called coverage control algorithm, I reposition the empty vehicles to the high-demand regions, so passengers who need a ride don't need to wait very long. This is a map of Shenzhen. The high-demand regions are shown in red. On the right, it shows a simulation that our algorithm in action. The empty vehicles are the blue dots, controlled by our algorithm. The empty vehicles are requested to go back to the high-demand regions after they drop off the passengers.
The mobility system is a complex machine with many intertwined cogwheels. It is therefore important that the developments in different areas ultimately fit together.
When I need to design a city, I need experts from economy, engineering, politics, I need a variety of fields. What is not well explored is the interaction of these different fields. Typically, these experts do not know the language of the other expert. So you need to provide an interface between them to abstract your field in a space in which you don't really care anymore about the technicality of what you're doing, that everybody can understand in the research community. And so I moved one step up from the expert. Now I am in a layer where everybody understands what's going on. And once I solve the problem, I go back to my lower layer, and I'm able to give very precise solutions to the single component owners.
The grand challenge of NCCR Automation is to create a new mobility paradigm where the competing operators that are managing the city, like traffic signal operators, bus operators, on-demand operators, cooperate in a way that they become more fair, equitable, environmental friendly for all the users in the society.